Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating bug fix within the Apache NuttX RTOS, specifically addressing a quirk in the uname command. The issue? The commit hash was mysteriously absent from the output.
That sounds intriguing. So the uname, a command, which usually provides system information, including the build's commit hash, was failing to show that crucial piece of data. What was the root cause?
Exactly. The article meticulously traces the execution path of uname. It starts by showing that the uname command in NuttX shell calls the uname function, which in turn relies on a static variable, gversion, populated by config_version_build. Essentially, the commit hash.
I see. So the problem wasn't with the command itself, but with how the version information was being handled internally?
Precisely. The investigation then delves into the build process, showing how configversionbuild is generated from the .version file during the build. They even checked the .config file to confirm it wasn't a configuration issue.
Clever! So they verified the commit hash was correctly built into the kernel image. But the problem persisted in the application, right?
Yes. They checked the kernel image using a hex editor to confirm the presence of the commit hash in the dig_version static variable. Then, the real detective work began. They called uname from both the kernel and the application, observing different behaviors. The kernel call worked perfectly, but the application call failed to show the commit hash.
Aha! That points to an application-specific problem. Did they find a difference in how uname was linked or called in the application versus the kernel?
That's where it gets really interesting. They disassembled the application's uname function and discovered that, unexpectedly, uname wasn't a system call to the kernel. Instead, each application had its own local copy of the uname function and the dig_version static variable. This local copy was somehow failing to correctly retrieve the commit hash.
So it wasn't a kernel-level bug at all, but a problem with how the application was linked or how static variables were handled within the application's memory space. That's a subtle and sneaky bug.
Exactly. The author even tested this hypothesis by creating a simple static variable in the application, and found that it was also empty, confirming that static variables were indeed broken within the application's context. This pointed to a deeper issue, possibly related to incorrect memory mapping during the build process.
Wow, that's a significant finding. So the seemingly simple missing commit hash led to the discovery of a much more serious problem with static variable handling in the application's memory space. This highlights the importance of thorough debugging and attention to detail, even for seemingly minor issues.
Absolutely. The article concludes by highlighting the importance of paying attention to even the smallest anomalies. The fix, thankfully, was contributed by another developer, addressing a data section mismatch in the application's build process. It's a great example of collaborative debugging and the power of open source development.
A fantastic case study in debugging. Thanks for breaking down this complex issue for us. It really underscores the importance of understanding the underlying mechanisms of an RTOS and the potential pitfalls of seemingly simple functions.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening. And we'll catch you next time with more exciting insights from the world of technology. Goodbye.
Bye-bye.